So to give a bit of background for the use case, Brevan Howard, we are a global macro hedge fund, multi-strat. We operate globally, which is like we have offices in New York, in London, we are in Geneva, we are in Abu Dhabi. We trade globally in almost all major markets, and we've been around for now a couple of decades. Traditionally, right, discretionary, which means like we were doing like human trades, like human beings were deciding on trades. A few years ago, the firm decided to make a big push into the systematic quant, the algo trading side. So one of the things you need for that is to build, a big central platform that can handle that flow, right? So they hired uh, the engineering team of which I'm a part of. We have Mike here, most of the PR folks, Ken, Avinash, Ted, team. We have folks in London. We have some in Abu Dhabi, France, Hong Kong, and so we started building. So the strategy is like we have dozens of PM pods, each team of their own, doing their own research, researching the alpha. And then the central platform would be taking care of everything from there. So the PM would be putting in the orders, the platform would be executing like the OEMS, the pre-trade risk, routing, internal netting, um, for equities like marking, locate, slicing the orders, everything happening in the central platform, common to all the PMs, connecting to the liquidity providers, and then the execution path back, right? So quite ambitious. We started working on it a couple of years ago, 2.5 years ago, and as we were building it, we found that, and as we were like scaling it up more and more, we found that we are spending a lot of time, um, you know, solving problems like how do you do snapshots, how do you restart the system, how do you provide like resiliency, what happens if this market connectivity fails, how do you like recover, stuff like that, right? And we are in fintech, but the tech is important, but the fin is important too. So we wanted to like focus on solving the business problems, and so we were like looking around at like what can we use, and then Aeron came up. So why did we choose Aeron? We wanted something that was a deterministic event source, which is like, it's a financial market. So given a set of inputs, you want the system to behave in the exact same, regardless of the load on the server, time of day, so we wanted that. Event source is just a nice way of doing that, which is like, everything is encapsulated in events which are making hops from one service to another. We wanted low latency because, we don't want stale orders, delayed orders, and we also don't want like the reports coming back because there's a lot of calculations happening, right? We have positions rolling up, open buys, open sells. We are doing locates and stuff. So we needed like, yeah, and we are like looking at dozens of PMs having multiple strategies, multiple asset classes. So it's like futures, future spreads, equities, FX, easily like 100,000 instruments. If you throw in options, probably millions, right? Once we do it. So and like we're looking at you know maybe like 40, 50 strategies where everything's ramped up across the PMs. So, we needed a certain amount of low latency, not high frequency, but a certain amount of low latency. But we also needed high throughput, which is very important. So, be able to sustain like maybe 100,000 orders coming in at the same time being dropped. Like, so that we needed some amount of resiliency, which is like, you have this system. What happens if you lose this fix? Or, what happens if one of the nodes go down, right? So, the ideal is like you have a system where one component fails and then another component takes over the role, right? And without a human being ever being needed, that's the idea, right? And everything that we have, like RAF consensus, consistent hashing, replication, the grid architecture, where you have no, they're all like trying to solve the same problem, right? So we found that Aeron did a lot of these pretty well, and that's why we went to Aeron. All right, so what are we doing on our central platform? So it's a multi-portfolio manager team that's globally trading through it. It's hosted on Aeron Cluster. So, like there's the Aeron transport, the archive, and the cluster. It's hosted on the cluster. We have a full execution system with OEMS, pre-trade risk at parent order, street order, 2 levels. We have fixed engines, we do positions, we do marking, we do locates. We have an internal netter that try to like net, you know, inside a PM across strategies and then across PMs. Yeah, and I mean, plenty of other stuff. So anything from a PM submitting order to the market and coming back. On the technical side or on the system side, we have added a few things to the to the Aeron cluster architecture. One is a persistent egress. So both of these are to handle data loss from the client to the cluster communication and back. So the persistent egress is on the way back. What happens if we lose data? So the cluster is publishing a data, data back to the clients. What if those are dropped? So it's written into an egress, a common archive. We use Aeron archive there, which the clients read of. So the cluster doesn't. So the cluster offer is not used for business messages. All clients are reading off the persistent egress. Also, it helps in, let's say we restart a client, right? So you can start from which offset to read from. So you can start from start of day, or you can start from the offset you left off for the clients, right? So missed messages. We did watermark and gateway management for the other way, where what happens if the client sends a message into the cluster and it gets dropped, right, for back pressure for some reason, right? So we have the clients storing the messages and periodically asking the cluster. So it's not an every message ACNAC, but it periodically asks the cluster, what have you gotten? And based on that, it retransmits the ones that it stores. On the fix side, so this is interesting. We haven't spoken about Artio, but for our fix, we are using Artio. So what happened is, like a year or so ago, my boss who's in London, he wanted us to build fix engines, and I said, like, we have worked with quick fix. We know it works. It's solid. It's well known. But there's this new thing we are using Aeron. So there's this new thing. It's cool. So let's use Artio because it's Aeron. And that's how we jumped into it. We have found that it's significantly faster. So we have several fix engines that we have built using Artio. Artio uses Aeron underneath. So we have an internal acceptor that accepts orders from the PMs who are initiators. And then we have external street-facing initiators that connect to the liquidity providers. So we have several initiators and one acceptor. We are working on a hot or active fix solution where if we lose one of the initiators, another one would be able to pick it up without asking for replay from the counterpart. So like just a connect disconnect. So that's what we're working on now. So this is kind of our system overview. We have the PM pods connecting to the gateway client, which is the acceptor, fix acceptor, sending in through to the cluster. We have several services, which are like the risk, the marking, locates, netting flows through that, and then it goes into the external initiators, the external facing initiators into the market, and then the path coming back, the execution reports coming back. So these are like new order singles, new order multis, cancels going out, and then execution reports, cancel rejects coming back, right? And we have the persistent egress. So the clients are reading off. So the one is like the nodes or the cluster doesn't initiate a conversation. Everything is handled by the agents. So like our rev data is submitted to the cluster by an agent, right? At start of day and as updates come, right? Fix or the orders are submitted by agents. We have a Kafka gateway. So one thing we decided is that there'll be a hot path, which is the orders going out and executions coming in, which would be untainted by extra load, right? So we have hot path applications or services, and then we have apps which are still real time but not hot path, like the plotter, let's say trade warehouse and stuff like that. So for that, we built a Kafka gateway, which puts the messages, the SBE messages, into Kafka, and the non-hot path read of the Kafka. The persistent egress is, again, it's like a follow the leader. So all of the nodes are writing to the archive, but only the leader is the one that's pushing back. It's similar to the way the nodes themselves publish, where each node is actually publishing, but there's a mock publish on the follower, and only the leader actually does the publish. It's very similar. I borrowed it from there. So, all right. So challenges. Challenges were like, coming from an object-oriented world where you like spawn threads, have executors and stuff going on, switching over to a deterministic model where, you can do those things. Not able to have concurrent or not wanting to use concurrent data structures, but having data belong to your agents or threads, and all communication happening through either one-to-one or many-to-one ring buffers. So, you don't have like a concurrent hash map where, two threads are sharing data, right? SB coding is very challenging, right? It's like, your decoders and encoders are fly bits, so you can store them, right? It's not like a Java Pojo, right? If you have repeating groups or varchar, you have to read all of them. It's like just before coming, like why can I be like debugging and troubleshooting cluster? It's hard. Some of the things like the logging and all we have to build in. I hear like there is more support now, but when we started there weren't. So we build all that in. So our support with adaptive has been a good experience, quite a good experience. We have bi-weekly calls with them. With James, he's there, and often we have other people joining. We do design discussions there. Come up with issues, ask for opinions, best practices. We do support tickets, emails. A month ago, Dimitri and I spent almost 2 hours out here debugging on an Artio problem, which we finally were able to come up with a workaround, but they have also patched Artio for that.